the problem here is talking about Pearson's correlation coefficient and the related topic of regression analysis. As we can see from the question number 1, you have measured the height of some men, 5 men, and you have also measured their weight. The question is there a relationship between the height and the weight of these men? And if so, is the correlation statistically significant? That is the question here. That is question number 1. The next question, that is question number 2, is a prediction and regression problem. So as you can see, the topic is regression analysis. The question is asking you, if you know the height of Peter Smith to be 82 inches, would you be able to make a prediction about how much he would weigh? So that is the next question. And these problems are going to be analyzed with SPSS. But just think about the problem for a minute. You have a certain set of data in problem number 1, the height and the weight. And you want to see whether there is a significant correlation between these two variables. Remember, the variables are all scale variables. In other words, they are measured on either an interval or ratio scale. So they are scale variables. When we go to SPSS, they will be entered as scale variables. And after running the analysis, we will look at the significance to determine whether the relationship between the height and the weight of these men is statistically significant. After we have determined that, we will then go on and see what the weight of Peter Smith would be knowing his height. So let's go to SPSS and do that analysis. Okay, so here we are in SPSS, and as you can see up here, I have entered the data for the height of the men and their weight. The height is in the first column and their weight is in the second column. Now remember, in SPSS, as soon as you enter any variable in the data view, as you can see, we are in the data view down here. Every variable you enter is immediately and automatically coded as VAR00001. So this is what SPSS did here in this column and in this second column too. But I have emphasized that you, the person entering the data, have to tell SPSS that you don't want that default VAR0001 name. You have to be specific in giving it a specific name related to the problem you are working on. So in order to do that, I had to go to the variable view. Again, the second tab in the lower left corner. As you can see, variable view, I clicked on that and I got my variable view and I typed over VAR0001 with the height for the first column and then weight for the second column. Now, just let me remind you, you can type anything you want here, but there should not be any spaces. Then I hopped over to the label and I labeled it as height of the man. And then the next important thing is I had to tell SPSS that the variables I have entered in the first column are scale variables. Now remember, if your variables are either interval or ratio scales, you have to say it's a scale variable. So that's why I selected scale. I come to the weight, which is the second column. I define it as the weight of the man. Now here under label, you can type with spaces. You cannot do that under the name. So that's the distinction. But under the label, you can type with spaces. So as you can see, there are spaces here. And again, I go to the last but one column here and I tell SPSS the variables I have entered, the weight, are all scale variables. If we go back to the data view by clicking the tab, you will see that the names that I gave the variables have now replaced the VAR0001 and VAR0002. So that's how you set it up. The columns are side by side. The first for the first variable, the second for the second variable. Now that you've done that, you are ready to analyze the data. So for analysis, you go to Analyze. And here, because we are looking at correlation, I'm just going to run the correlation first. But the two are related. Indeed, you can do the two in one, but I'm just going to break it down and show you how to do the correlation. Under Analyze, you will see Correlate. Now, we are looking at two variables, so it is a bivariate correlation. So I go to the next button and I select bivariate. And I have run this before, so I'm going to reset it so you will see what I saw when I started it. So if I reset, the variables that I have entered in the data view will be shown in the left side of this screen here, this short pop-up screen. These are the variables I've entered. I need to move them under the variables column in order to analyze them. Now, before I do that, let's look at the bottom here. You will see it says correlation coefficients and Pearson is checked for me because intuitively SPSS knows that's the variables that I've entered. Under test of significance, it will check two-tailed by default, but we don't want two-tailed. We always are looking at one-tailed test. So move the button to the one-tailed test, and then you will see flag significant correlations already checked because SPSS wants to tell you, hey, look here, this correlation is significant. I flagged it for you. That's why this is checked by default for you. Now let's go back to the variables here. I have the height. I click it, hold down the control key and click on weight. So you select the two variables. Click height, then hold the control key and select weight, and then click the middle arrow here to move them under the variables column as you see here. Now that I've done that, if I want to have the statistics, that is the descriptive statistics for my variables, I can go to options and I can select for the output or the result to tell me the means of the height of the man and the means of the weight of the man. So I can check means and standard deviation as my descriptive variables. And then I'll click continue. Now that I've done that, I have set this whole thing up for analysis. So all I have to do is click my OK button, and here is my analysis. As you can see here, it gives me the descriptive statistics. The mean for the height of the man was 70. The mean for the weight of the man was 160. The standard deviations are given 2.54 and that for the weight is 20. The numbers that I entered were 5 variables each for the height and the weight. So that is the descriptive. Now I go down here and I'm looking at the correlation, and as you can see here, the correlation is put in the two columns, the height and the weight. 3. Now if you look closely, you will see the asterisk here, and the asterisk tells you what it means. It says correlation is significant at the 0.05 one-tailed level. So it is telling you that the correlation between the height of the man and the weight of the man is statistically significant. That is, there is a positive correlation between the two variables I have entered. Now, Beneath that, beneath the correlation, you will see the actual probability of the result, and it is 0.040. If you recall from the earlier lecture, it stated clearly that whatever correlation that you get, it has to be tested for the probability of this result happening out of pure chance. Now, this probability is what is telling you that the probability of getting such a correlation of 0.833 out of pure chance 4 times out of 100. Now remember, from the earlier lectures, we said if you get anything that is 5 times out of 100 or less, then that cannot be said to be any longer due to chance. It must be due to something real that is happening. Probability that is less than 0.05, that is 0.05 is good, 0.04 is good, 0.03 is good, 0.02 is good, 0.01 is good. Anything that is 0.05 or less is statistically significant when we are looking at the probability. So when you see any analysis at all, the first thing that you must look at is not the actual analysis of this 0.833, but you should look at the probability first. If the probability is 0.05 or less, in other words, 0.05, 0.04, 0.03, 0.02, 0.01, anything of this nature is statistically significant. It is good. If the probability is 0.06, 0.07, 0.08, 0.9, anything of that nature is not good. So what we have seen here, because the probability is 0.04 and it is less than the conventional alpha level probability of 0.05, this correlation of 0.833, a positive correlation by the way, is a statistically significant correlation. It's a statistically significant correlation between the height of the man and the weight of the man.